And so we're going to get this going. Sorry about that. Come on. And all right. Okay. So here is my second solution. Okay. So those are my two solutions. Done. All right. So making sure that you set it equal to 0, factor it, both of those are done. Then take each factor, set it equal to 0, and then solve these equations. And those are my solutions. Questions? Okay. All right. So number 2 here, we have t's instead of x's. It doesn't make any difference. We're still looking to solve the equation. So all of these directions are going to say solve, okay? Every one of these is going to say solve. Notice that on the right-hand side, I have set equal to 0. Everything is good there. So step number 2 says that I need to factor this. And this is why it was so important that you factor and you practice factoring. So I'm going to factor this. As I look at this problem, I'm going to have a t here and a t here, okay? So I'm going to ask you guys to help me out and tell me what the factors are here. You can chat them to me. I would rather you chat them privately so that everybody doesn't see. So tell me what my two factors are going to be here. Remember, the product needs to be 20 and the sum needs to be -8. Help me out with my factors. Making sure I can see the chat over here. This is what we did yesterday, just factoring this. Yes, so I have t minus 10. Yep, I'm getting lots of these good ones. And t plus 2, okay? Now, be careful because this is not my solutions, okay? Now, here's where I get really stinky, nasty, mean on multiple choice, okay? I might put -10 and +2 as my solutions, but those are not my solutions. Those are just my pieces of my factor. So be really, really careful here, okay? Now the next step is that I take each of these factors and I set it equal to 0. So I take t minus 10 and I set it equal to 0, and I take t plus 2 and I set this equal to 0. And then I solve for t. So I add 10 to both sides and I get t is equal to 10, one solution. I subtract 2 from both sides and I get t is equal to -2, second solution, okay? So be super careful there and make sure you get to the end where it says variable equals a number before you ever look at those multiple choice answers, okay? Questions? All right. I think y'all are getting much better at factoring. Y'all are starting to catch on to that really quickly. So that means that I'm going to be really quiet on this next one. I know that's so stinking hard for me to do. And I am going to just write it like this. It is set equal to 0, so we just need to factor it. And I want you all to privately tell me what the factors are. Make sure you include the m pluses, m minuses, whatever we happen to need to have. Those are not factors. I'm not going to accept that as an answer. Make sure you tell me whether it's m plus, m minus. There you go. I like that better. Trying to make sure you're paying really close attention to signs and variables and all kinds of nasty little things like that. I love the numbers. I just don't like format. Ooh, I like that. Very nice. There we go. I'm getting beautiful answers. I get so happy when y'all contribute. Okay, I can't type. I'm sorry. Some of you are giving me numbers, and the numbers are fabulous, but I'm also sending you a message back that says, can you put those as a factor? Can you write those as factors? That's much better. Much better. Okay, so I really, and the reason I'm not trying to be picky and a pain in the tail. Whoa, hello. I really want to make sure you understand the difference between factors and solutions. Okay, so the factors are going to be, and I've seen most of you tell me this, m plus 5 and m plus 8. Several of you tell me 8 and 5, and that's beautiful numbers. The product is 40, the sum is 13. That's fabulous. But my factors are m plus 8 and m plus 5. Now, I am going to take each of those factors and I am going to set them equal to 0 in order to solve for m. So each of these factors set equal to 0. Solving these little equations for m. The first one, I subtract 5 from both sides, and I get m is equal to -5. Solutions. So these are my solutions here, okay? And then when I subtract m from both sides, I get m is equal to -8, and then these are my two solutions, okay? So again, this line is my factors. Okay, so when I write it like this, I have factors, and then this line is my solutions. Okay, so 10 and -2, or -5 and -8 are my solutions. So be real careful and make sure you know the difference between the factored form and then the actual solutions, because these problems are going to say solve or find the solution. Okay, so that's going to be my final end result. So be really, really careful there. Okay. All right. Next. So again, first thing I check, is it equal to 0? Yes, it's equal to 0. So then I look to factor. Now the difference here is that in the previous problems, the previous two problems, I had a trinomial. I had 3 terms. And the problem before that, it was actually already factored. Here, I only have 2 terms, and it's not factored, and there's a plus between the 2 terms and a squared here. So I might be a little bit concerned because I told you yesterday you couldn't factor the sum of 2 squares. This is not the sum of 2 squares. Yesterday, when we started factoring, I told you you had to always look for something. When you get ready to factor, I told you to always look at the problem and see if you had something. Does anybody remember what that something was that we had to look for before as we started to factor any problem, especially those first ones that always had one? Does anybody remember what that was that we had to look for? I am open to suggestions, either privately or out loud, or you can answer to everybody. What did we always look for when we factored? Maybe a better question would be, what was the first factoring technique we talked about? Started with the G. Yep. It was. I got at least one answer. See if I can get one more answer. Okay, I got another answer. It makes me happy. Okay, so greatest common factor. Okay, so we look for a greatest common factor. So now that I've told you what it is, somebody needs to tell me what is the greatest common factor on the left-hand side here. I have a 2x squared plus 12x. What is my greatest common factor? Got a 2. I got one other thing that's in there as a greatest common factor. 2 is a fabulous common factor. And an x. Excellent. So 2x is actually my greatest common factor. That leaves me with 2x squared divided by 2x is an x. And then 12x divided by 2x is 6. So I have 2x and then x plus 6. And this product is equal to 0. So this is my factored form. So these are my factors, 2x and x plus 6. Okay, so that's a little bit different looking than the two binomials we had in the previous problems. But this is still my factored form. Okay, so I'm still going to take each factor, 2x, and set it equal to 0. And I'm going to take my second factor of x plus 6, and I'm going to set it equal to 0. And I'm still going to solve for x. Now in this first one, I'm actually going to write this down because it confuses some people. I'm going to divide both sides by 2, but now we know that 0 divided by 2 is just 0. So x is equal to 0 is one of my two solutions. That's a perfectly legitimate solution. The second one, I'm going to subtract 6 from both sides, and I get x is equal to negative 6, and that is my second solution. So my two solutions are 0 and negative 6. Okay. Guys, you can check these. I didn't tell you that on the first ones, but you can always check. When you have an equation to solve, you can always check them. And so if you want to check these, and I'll just show you here on this one, if I check x is equal to 0, I'm going to plug 0 in for x. So I have 2 times 0 squared plus 12 times 0. This gives me 0 plus 0, which is equal to 0, and that's what I need it to be. When I check x is equal to negative 6, I have 2 times negative 6 squared plus 12 times negative 6. This is 2 times 36 plus negative 72. 2 times 36 is 72 plus negative 72, which is indeed 0, and it checks. So you can always check your solutions by plugging them back in, okay? So make sure you realize that, because that's just a fabulous way to make sure that you're working these problems correctly, okay? All right. Number 5 down here is, again, two terms. The two terms do have a minus sign in between them, and it is the difference of two perfect squares. So it is set equal to 0, so that's the first thing we need to check. I'm set equal to 0, life is great. So then we need to factor, okay? So when I factor this, I am going to factor it using that formula that we had yesterday of the difference of two squares. So that's what I have here. So this is going to factor. I told you we wouldn't have to use the cubes, but I didn't promise you no squares, okay? So this is going to factor. Somebody help me out with my factors here. Difference of two perfect squares. 9 and 9 is 81. So I like that. I'm going to put that in. But I need to know what comes before that. You got a Y. I'm good with the Y. I need something to go with my Y. I'm going to get this out, y'all. How did I get the 9? I took the square root of 81 to get 9. I take the square root of 9 to get 3. Yep. Now, what signs do I have in here? Excellent. Except I need a 3. I need a 3 on there. So I'm going to have a 3y plus 9 and a 3y minus 9. Excellent. Very good. See, I knew I would pull it out of y'all eventually. It just maybe took me an extra step. Okay. Don't lose the 3 part because I do have that 9y squared. So that's really important. Okay. These two actually do have a greatest common factor, so you might have factored, in fact, somebody might have tried been doing that. You might factor out that greatest common factor there of 9. That's okay. You're going to get the same answer. I'll actually work that separately in just a second. But most of the time when I see that 9 there, I say, oh, okay, that's a perfect square. So I'm going to take each of my factors, 3y plus 9 is equal to 0. I'm going to show you how this works. And then 3y minus 9 is equal to 0. When I solve this first one, I get 3y is equal to negative 9. Dividing both sides by 3, I get y is equal to negative 3. One solution. There's solution number 1. And then the second one, I'm going to add 9 to both sides. So I get y is equal to positive 9. Dividing both sides by 3, I get y is equal to 3. So these are my two solutions. Y is equal to negative 3 and y is equal to 3. Okay. Now, I do want, if you were like, okay, I'm good, I'm finished, I'm fine, so that's okay. I am going to show you an alternate way to do this where we do have a greatest common factor. So, and there's absolutely nothing wrong with doing this either way. So an alternate method is to take out that greatest common factor of 9. So we can factor it by saying, okay, there's a 9 common to both of these, and so I have y squared minus 9. I still have 9, and the reason I'm doing this is because I want you to see what happens with that 9. So this is going to still factor into a difference of squares, so 9, y plus 3 and y minus 3. But when I take my factors and set them equal to 0, the only things I'm using are the factors with the variable in them, okay? And so I get y is equal to negative 3 and y is equal to positive 3. Notice I don't do anything with that 9 factor, okay? So it's an alternate way to do this. I had to use the 2x here because there was a variable. The difference is in this one, there's no variable attached to the y that was a common factor. Here, there was a common factor with that variable in there. And so that's why I got a solution out of this factor, but I'm not going to get a solution out of the y. So sometimes I don't show that, but I think a couple of you, just based on your comments, were seeing that as an option. And so just be real careful there and just make sure you don't try to set 9 equal to 0. Because if you do, 9 can't be equal to 0. Questions? You doing okay? Because you know I'm going to make it harder in the next one. Just a little bit. Not much, just a little bit. All right. So problem number 6 has an issue. What is the issue? I'm Come on, let somebody tell me what is wrong with this problem. Why I can't just, there you go. It is not equal to 0. I'm getting several people telling me that. I have a problem. I need to move this 6, okay? So, but the other problem is that my left-hand side here is factored. So if I don't have 6 on the right-hand side, okay, so not 0, if I don't have 0, if it's not equal to 0, okay, then I've got to go through a process to get that 6 over there. So what that means is that I want to multiply the left side. Okay, so I'm going to actually go ahead and multiply these two terms together. That's going to give me x squared minus x minus 2x plus 2 is equal to 6. Okay, that's the first thing I've got to do. I've got to multiply out the left-hand side. So if I have factors and it's not set equal to 0, then I've got to multiply my left-hand side. Those factors do me absolutely no good over there, not equal to 0, okay? So I'm going to simplify this left-hand side. I get x squared minus 3x plus 2 is equal to 6. Now I can move the 6, okay? So now I'm going to set this equal to 0, and in this case, by moving the 6, okay? So I'm going to have x squared minus 3x plus 6, plus 2 minus 6, and this is going to be equal to 0. And so I'm going to continue simplifying this. I could have done it all at once. That's perfectly fine. If you could go from this step right here to this last step, that's perfectly fine. There's nothing wrong with that. I just wanted you to see that that 6 moved over, okay? So now I'm back at the same point I was on those previous problems. I have a quadratic equation. It's set equal to 0. And so life is great because the next step is to factor. All right. So now I'm going to factor, and I'm going to factor this really lovely trinomial into something. So you guys help me out. Tell me what the factors are. Send it to me privately, not to everybody. Make sure you have factors and not numbers. Okay? So what are my factors here? Excellent. I'm seeing some answers. I'll give y'all a couple more minutes. Kind of like I told you yesterday, factoring is so easy when I do it. I get this all the time. It's like, it's so easy when you do it. Yeah, well, I need you to be able to do it too, so. Make sure you're giving me factors and not x's. There's a big difference there. So a couple of y'all, I'm going to get you started. Some of y'all are doing a phenomenal job, okay? Remember, this has to be x and x, and then I'm going to have two numbers here and here, but this is not what x is equal to, so be really, really careful here. So when you send me your answer, make sure it says either x plus or x minus things here. Couple more, folks. Wait for a couple more answers. I think some of y'all have gone to sleep on me again. I'm convinced y'all like watch other videos or just take naps. Coffee break. All right. I got my other answers. Fabulous. Okay. So I have several people who told me very correctly that I have x minus 4 and x plus 1. Gives me negative 4 at the end. When I add negative 4 and 1, I get negative 3 in the middle. These are my factors. Guys, if you put negative 4 and 1 as your answers, it's going to be wrong, okay? So make sure that you get your factors, and then we take each factor and set it equal to 0. X minus 4 is equal to 0. And I take x plus 1 is equal to 0. And so this is going to give me solutions of x is equal to 4 and x is equal to negative 1. And these are my solutions. So be really careful here. Make sure that you are seeing the difference between the factors of x minus 4, x plus 1, and the solutions of positive 4 and negative 1. Because I'm telling you right now, multiple choice questions I will have for you to choose from for negative 1, negative 1 and positive 4, negative 4 and negative 1, positive 4 and positive 1. I am really, really good at figuring out what kind of wrong answers you guys are going to come up with. So don't do the wrong answers, okay? I need to make sure you can factor and solve these equations. Because I told you the other day, this is something you're going to continue to have to use. Okay? And at some point, this becomes a small portion of what you're going to be doing. Okay? All right, let's look at another problem. Okay, tell me what makes number 7 different than every other problem we've worked today. Somebody tell me what makes number 7 different than every other problem we've worked. This is one of those things. It does have a variable that's different. You are so correct. See, y'all come up with the best answers, but there's something else that's different. It does have a different variable. I will give you that. Something else that makes this one different. Go back and look at the other problem, because it's the only one that has this that we've looked at today. Aha! That's a very good answer. I actually like that. I know y'all don't know what it is because they only sent it to me. I'm going to keep it a secret. That's good. I'm going to see if somebody can say it a little bit different way. You see, because this is one of the keys to recognizing how to work these problems is to say, why is this different than everything else we've done? So what makes this one different? Other than the fact the variable is y. So I'm going to go backtracking. And I'm going to start with this one. What's the power on t here? What's the highest power on t here? It's a 2, right? What's the highest power on m here? It's a 2. What's the highest power on on number 4 here, on x? It's a 2. What's the highest power on this one? It's a 2. This one we had to multiply out, and the highest power was a 2. What's the highest power on number 7? Is it a 2? It's not. It's a 3. Okay? Somebody said it really well by saying every one of these terms has a y in it. Okay? So whether you recognize that it's a y to the third, which we haven't had yet, or you recognize by saying that every term has a y in it, then that tells me that we have a greatest common factor. Okay? So that y to the third, and I promised you wouldn't have to use that difference or sum of cubes formula, and we don't, because we have 3 terms here, not 2. Okay, 2 is when we have sum and difference of cubes. We have 3 terms here. Okay, and yesterday when we talked about factoring, you had 3 terms. You always look for that greatest common factor, and so in this case, because of that y to the third, that should send like this big giant red flag that says, hey, something's wrong here, right? And the something wrong or something different is that I have that y to the third. I don't like y to the third. It's not the sum or difference of cubes. But then I look and recognize that all of my terms have a variable y in them, and so I can actually factor that out. It is set equal to 0. That's lovely, okay? If it's not, then we would have to go through that same process. But it is set equal to 0. So I am going to factor by starting off with the greatest common factor of y. And so I have a y, and then that's going to leave me with a y squared minus 14y plus 48 is equal to 0. And so now I can continue factoring, okay? So continue factoring this. Do not lose this y because it's incredibly important. It's not like the 9 we had in the previous problem. So now I can factor my y squared with my 2 y's, okay? And factors of 48 that are going to give me negative 14 are going to be negative 6 and negative 8. That gives me a positive 48 and a negative 14 in the middle. And so now I'm going to set my factors equal to 0 and come up with my solutions. So I want you to send me in a private message. I need everybody to respond with the solutions to this. Make sure you send it just to me, not to everybody, because I want to make sure that each of you gets this before we go on any further. Okay? The solutions now. So because I want solutions, I just need numbers. Okay? So send me your solutions. And your solutions are going to mean your attendance for the day. So if you don't send me a solution in a private chat, you're not going to be here. So far, I only have one person who's gotten it completely right. And I sent them a message that said yes. So far, only one person has gotten it completely right. Most of you are very close. Okay, I have 2 people who've gotten it right, and you've both gotten a message that said yes. If you didn't get a message from me that said yes, then that means you're not completely done. Gotten a couple of more correct answers, but you've all gotten a yes. One of you had descended in 2 parts. Make sure you're setting each factor equal to 0. That's my hint. Make sure you set each factor equal to 0. I'm getting answers, but I'm still not getting all of the answers. I should tell you something. Okay, somebody who got it correct, who got a yes. Let's see. Who else? Let's see. I'm trying to see who all has replied. Like I said, this is your attendance for today. Oh, we're so close. We're getting some of the answers, but not all of the answers. Still waiting for a couple of people to respond. That's okay. I'm okay with I'm not sure. That's fine. That is a perfectly acceptable answer at this point. So y'all are doing. I'm looking. You see, I'm looking. I'm missing. Making sure I'm not missing those. Okay. All right. I got a couple people who've gone through for me. All right. So, Raven, are you still here? Okay. All right. So let's figure out how to solve this. So some of y'all did great. You got 2 of the, how many solutions are there? Somebody who got a yes. How many solutions are there? There are 3 solutions. That is correct. Y equals 0. Y minus 6 is equal to 0, which gives me y is equal to 6. And I set y minus 8 equal to 0, which gives me y is equal to 8. And so my 3 solutions are 0, 6, and 8. Okay? Be careful. That y to the 3rd power, that 3rd power tells me 3. That tells me 3 solutions. Okay? Don't forget that little y equals to 0. That 9 didn't have a variable on it, so we couldn't set it equal to 0. With the y by itself, we can. Okay? Questions, questions, questions. All right, so here's what I'm going to do, guys. Y'all are doing so well on this factoring. So at this point, I don't really want to work a whole bunch. Okay, perfect, excellent, good. So if you still have questions, I've gotten a couple of good responses back. So anyway, so if you still got questions, stick around. I will answer them. What I am going to do is I'm not going to disappear from the WebEx. I'm going to hang around here for, I don't know, at least 30 minutes or so. So if you want to work on homework, if you want to drop off of this and work on homework, you're perfectly welcome to do that and then come back and ask me questions. If you just want to go work on the homework on your own and say, bye, I'm done, then that's your business too. Please make sure you remember to send me questions about the material that's going to be on your test, okay? Because Monday, I really do want to work a whole bunch of problems for y'all. I can make up problems to work, but it's not nearly as effective as you send me the questions that you have, because then I know what you need to know, right? I might just work random problems, and it might be you're going, I know how to do those. These are the ones I don't. So I need to know the ones you don't know how to do, okay? So send me those questions in an email. Send them to me before Sunday evening. So it doesn't have to be today. It can be tomorrow. It can be whenever. Just send them to me by Sunday evening, and that's we'll work those, and hopefully I don't have to come up with other ones. And then test is on Tuesday. This is the last material that's on this test. So go work on homework or stick around and ask me questions. So, but otherwise, have a good weekend.
I